All right. Very good morning, very good evening, everyone. Um, Again, let's continue with this one more demo classes continuation to the our yesterday's class. Quickly, I can recap what we discussed yesterday, and then we'll get started with today. So we started with the introduction, right, and then uh, we started with the course curriculum, and then we started with the course curriculum and timing. So what timing, what are the demo classes, when the actual class is going to start, and what is the course fees. All this we discussed. Quickly, I can recap one more time on that. So two of these are like demo classes yesterday and today, 7 Jan and 8 Jan. 2 hours of demo classes I was planning to conduct, and one we successfully completed yesterday, and today is the second demo class. And this is a link what you guys are attended. The course fees are 15K INR, and the actual course is going to start on 14th Jan. As one more time, I can repeat it. So these two classes are demo, Saturday and Sunday, 7th and 8th Jan 2023, followed by next weekend, 14th Jan is the one we're going to start the actual class. So this is the weekend batch, right? So as I already mentioned, this is the only weekend batch. This RAC course is on weekends. So this is a weekend batch. We're going to conduct only on Saturday and Sunday. Classes are only on Saturday and Sunday. Uh, 4 hours on Saturday and 4 hours on Sunday. Starting with next week, 14th Jan onwards. So 4 week on Saturday and 4 hours on Saturday and 4 hours on Sunday. Totally 8 hours in 1 week. So we're going to use approximately around 6 to 7 weekends. So we'll start with 14th, 21st, 28th, 4th of Feb, and next followed by the next weekend. So by 6 to 7 weekends, we're able to complete this entire course, right? That's about brief overview of course duration and course fees and the course timing. And if you're looking for the course curriculum, you can go to my blog and you can check for this link, RAC training. Already opened over here. So we already discussed in detail about course curriculum, what is included and what is not included, and if anything need to be included, that will be taken it as extra classes. Right, so you can go through this course curriculum, and on top of that, we discussed we have a dedicated WhatsApp group for those who are registered for this course. All the communications will happen through WhatsApp group, and then once you registered with the course, you will get access on all the PPTs, workbook, lab materials, softwares, and ready labs, and all the practical sessions, and along with that, previous class recordings and on this ongoing class recordings. And every day sessions will be recorded and uploaded to Google Drive. You will get access on those recordings. You can watch it in case if you're not able to attend. Right. With that, what we're gonna plan today, I'm gonna followed by that's what we covered yesterday. And then we started with the RAC architecture. We understood what's the difference between standalone versus RAC, why RAC is so important. One of the important feature is your high availability. That's what we discussed. Standalone, if the instance crash happens, your database is unavailable. In case of RAC, instance crash happens, you have other instance to survive that incoming connection or existing connection. Right. There is a question here. What's the EST timing? Yes, that's correct. 9:30 PM EST to 1:30 AM EST. That's a correct timing in EST. And then we started understanding RAC networking, and in that we started understanding couple of IPs. One is public IPs, and other one is private IPs. And the public IPs are nothing but typically we can call it as a public network, and private IPs you can typically call it as a private network, right? And then we started understanding furthermore on the RAC what all IPs are needed. We understood about our node IPs, or typically we can call it as a physical IPs. And we started understanding node VIPs. Those are like simply you can call it as a VIPs, and scan IPs. So again, those are nothing but your VIPs. Right? So these are what are the IPs are needed. Public IP and private IPs are general terms, like public network and private network, general terms in network field. But in case of especially RAC, when you start building up your RAC, you need a node specific IP. Those are the physical IPs. You need a node specific VIP. Those are the virtual IPs. You need a scan VIP. Those are the again VIPs. And you need node specific private IPs. Again, those are physical IPs. Right? These are the IP understanding what we did, and couple of little bit of administration part we talked about, like shutting down your cluster, and a lot of questions around the database startup and all those things. Right. With that, what we're going to cover today, we'll understand a little bit about. We talked in short note about why these many IPs, node IPs, and why VIPs. That VIPs means like node VIP. And then say why scan IP, or you can call VIP. Your scan is always a VIP. Some people will call it as a scan IPs, and some people will call it as a scan VIPs. Both are same. We're going to use only VIP for scan. So we'll understand a little bit on why node IPs, why node VIPs, why scan IPs, and why scan VIPs. Let's go to diagram here. So this is a typical architecture in detail with the networking explained over here. If you see, this is considering 4-node RAC cluster. You have node 1, node 2, node 3. You have node 1 here, node 2, node 3, and node 4. 4-node RAC, assuming this is the 4-node RAC. And this node has its a node IP here, 101.101, 102, 103, and 104. 4 node IPs. Those are like physical IPs tagged to your interface. Yesterday I showed that interface, how the physical IPs will be tagged, right? So these are the node IPs tagged with that interface. That is a public network. And each node has its own VIPs, 105, 106, 107, 108, right? All these 4 node has 4 node VIPs. These are the virtual IPs. And again, these are like pegging. It will not be having any physical interface. It will be just pegging with the interface what this node IP is tagged with. It's just gonna peg with the :1, :2, :3 like that. These are like not a physical IPs. These are the virtual IPs, which will be not having any specific interface, and it will be just hanging inside my cluster. And each of these node has a private IPs. These are private IPs, whatever marked in red color here, these are private IPs. And if you can observe by looking at this different subnet here, 2 dot, these are like 1 dot, those are public subnet, and this is a 2 dot, that's a private subnet. So you can call it as a private network, or the private interconnect, or the network interconnect, which will be helpful for only node to node communication or node to disk communication, and which these IPs will not be accessible outside of the world. So these are like private within your network, within your organization. So these are your private network here, 4 nodes. These nodes specific for private IP addresses. Again, these are physical IPs. Physical IPs means it is pegged to your interface or the NIC cards. Right. So this is overall IP what all needed. We need all together here 12 IPs to do this 4 node configuration. And we have this scan here. We have 3 IPs, again same series, 192.168.1. Public IP range, 1.200, 1.300, 1.400. 4 VIPs are needed for my scan. In prior to 10G, there is no scan, there is no uh, scan, and there is no VIPs. There is no only node specific IP. And then what used to happen in that case? There are a lot of manual effort when they prior to 10G, when Oracle released this OPS, Oracle Parallel Processing System, there are nothing called VIPs or there are nothing called scan. It's all like uh, node specific IPs. And then what used to happen there? Let's understand a little bit. Okay, I'll open that diagram what we draw yesterday. And then we'll start with that. Where was that one? Okay, anyway, we'll draw one more time. Let's take it over here. Right, let's draw one more time. We have a 2-node rack setup, assuming that it's a prior to 10G. There we had Oracle Parallel Processing System. So it has a node and say node 1 and then node 2. And assume that if there are no scan, no VIPs, and end users who are going to connect to my system, I'm going to give like this. For them, I'm going to give something like this. I'll just give one TNS details. Right. I'm going to give something like this. For those who are trying to connect to my server, I'll just take it as only 2 IPs. Node 1, node 1, and node 2. Okay, let's put it in a format here. Right. So this is a typical, your database is ORCL, and when you don't have a physical IP, just a node IP. And when you given this node IP, what used to happen here? All the connections, whatever that end users are connected, you're going to use this TNS details. In that TNS details, you used to mention node 1, node 2, and load balance equal to S. And assuming that these are the 2 nodes, you have a client 1 coming. This is your client 1, and this client is going to connect to my database, either node 1 or node 2. Any one of the node it used to go because of this load balance equal to S. We used to mention that load balance equal to S at the client side itself, and client side that TNS used to manage. One connection go to node 1, one connection go to node 2. It kind of a round robin, it used to send the details. Right, so 10 connections came, and then 5 connections went on node 1, and then 5 connections went on node 2. And then later what happens? These 5 users are dropped here, and only 5 users are there. And remaining 2 more connections come here. In that case, what used to happen? Your client side load balancing out of those 2 connections. Okay, 1 connections go here, and 1 connections go here. It is not like actual load balancing. It used to round robin. Okay, 1 connection comes, go to node 1. Second connection comes, go to node 2. Again, another 10 more connection comes. 5 connections go here, and 5 connections go here. It used to distribute that load in a round robin fashion. It doesn't matter whether all those connections here connected are all dropped, or actually how many connections are available here, how many connections are available here. Based upon that, it has to suppose to send the new connection to that least loaded node. But since we don't have a VIP, since we don't have a scan, it used to send it a round robin. It is not an actual data load distribution here. All the connections are random here. Like, everything round robin it used to go. But some people can do more work or some people can do less work. In that scenario, actually that does not serve the purpose of load balancing. And then that's a one disadvantage. Load balancing was becoming a challenge here before 10G, right? One is load balancing not proper. And the second thing is, in case if this node goes down, what used to happen? Again, one new connection comes. Since that they're using this TNS entry, your client used to connect that connection to node 1, and then node is not available, and later it used to send it to node 2. Even though node is not available, it used to send that connection to that node which is offline. It's again client side used to get the TNS connection error, and then later they used to pass it to the other existing node, right? That is a tedious job because the client side they don't know whether the node is up or node is down. That is your second issue. Node down can't be handled. That is prior to 10G. And the third issue, what used to happen? Assuming that 10 clients are connected here, 10 clients are connected here. What used to happen? If this node goes down, all these 10 connections are kind of a waste, disconnect. There is no mechanism to fail over those 10 connections to other existing node. So that is the third challenge what they had it. Right? So that's we can call it as a TFA, transparent application failure. So TFA means just mention failover. Failover is not supported. Right? So these are the challenges without your scan and without your VIPs. With the help of only node specific IPs. That's the first what Oracle has challenges. And later to overcome that, they introduced VIPs in 10G. In 10G, Oracle 10G release, they introduced the VIP concept. What is that VIP concept? So same thing, they used to, instead of node specific, they used to give VIP addresses to the clients and load balanced equal to S. Again, in this case, these challenges remain same. Your client side, they will not be able to get the proper load balance. Again, as I said, client 1 comes here. Let's remove all of them here. Right. So like client 100 client came, and then out of 100, like 100 clients are connected to node 1, 100 clients are connected to node 2. And then later these all 100 clients are done with their job and they logged out. And only node 2 having this 100 users still connected and they're processing, heavy processing they're doing. And remaining next connection comes in a round robin fashion, it used to go here. And next second connection comes, it used to go to here. So still the new connection used to go to node 2. Ideally, it should not go to node 2 now because node 2 already overloaded. 100 connections are available. Whatever the new connection comes, 3 go to node 1, 4 go to node 1, 5 go to node 1, 6 go to node 1. So your client has to send all the connection to node 1 because already node 2 has 100 connections. That kind of an intelligent mechanism will not be able to achieve if you use this client side load balancing here. Whatever this TNS name we are doing this load balancing, they will not be able to achieve. Even with the VIP, when they came up with this VIP concept, still the load balancing is challenging for them. And then what they achieved with the VIP concept here, this load balancing they achieved. Sorry, the failover they achieved. What that failover, we already know that if the any client is connected to VIP, for example, if this client 1 connected to node 1 via VIP, and then what happens if this node goes down, automatically this VIP will never go down. It will be just floating in our cluster, and that will not go down. And these all the client connected here, for example, 10 clients are connected over here, 10 clients are connected over here. And if this node goes down, these 10 connection clients are floating in my cluster, and this existing node will take over all those incoming, all those 10 client connections. With the help of VIPs, what they did in 10G, they are able to achieve this failover. Right, let's go back here. Right, with the help of this VIP, they're able to achieve this one. Right, the failover they achieved, but still the load balancing is an issue. They did not able to achieve. And if the node goes down, again, that's a challenging. If the node goes down, again, that's challenging, is an issue. Because what happens if the node goes down? Now 10 clients are connected to node 1. With the help of VIP, they're able to achieve this failover. And the next incoming connection comes. For example, 11th connection comes, and then your client will try to send it to node 1, and then later it'll get to know, okay, node 1 is down, let's go to node 2. So till they're sending wrongly the incoming connections, your client side, they're rerouting it to that node which is down. Again, that's a kind of a delay for the client connections. So that is still an issue here. With the help of VIP in 10G, they're able to achieve this load balancing. But sorry, they're able to achieve this failure scenario. But load balancing and node down situation, still they will not be able to achieve. And in 11G, what they did, they came up with a concept called scan. That is came in 11G. So what happens in 11G? They're able to achieve all of these things. How they're able to achieve? So instead of this node VIP, or instead of this node IP, they came up with a scan concept. Let's put it here. What they did, don't need to put the node specific VIPs or node specific IPs. Just put scan, whatever your scan, just put a scan name here. The moment they put the scan here, they're able to achieve all these, whatever the challenges they had it. They're able to do this load balancing properly with the help of scan is achieved, and node down situation also they achieved. How and why the scan is able to understand smart enough here? Let's take it example here. Right. What they did here, directly the client connecting to node or client connecting to VIP, they came up with a concept called scan here. So let's give the scan name to this client. Don't give just give the scan TNS details to your client. Don't give the node VIPs, or don't give the node IPs. This is a node specific IP TNS details. This is a node VIP specific TNS details, and this is scan specific TNS details. Always give a scan details to your clients or the end users or the application users. They has to connect with the scan. What happens if they connect with the scan? And client connections first will go to scan, and scan is smart enough. Scan is already knows this node 1 has a 10 users, node 2 has 100 users are already connected. Client 1 comes, scan automatically route connection to node 1, and the second client comes and they'll connect to scan. Already scan knows, okay, node 1 now it become 11, and node 2 already having 100, go to node 1. Again, third connections comes, they will connect to scan. Scan already has that information. Okay, node 1 already having 12 connections, node 2 having 100 connection. Let's go to node 1 again. It will become 13. Again, scan, fourth client comes to scan. Scan will send it to node 1, it will become 14. Scan is properly able to understand which node, how many users are connected, how much data is processing. And based upon that, scan is able to do this proper load balancing on my cluster side. That's a one major task what scan has able to handle it. Where in 11G and prior to where in 10G and prior to 10G, where we are not able to handle the proper load balancing. Right. That's one advantages why scan can able to properly do a load balancing. And then what happens here, scan, if the users are connected to scan, via scan, the scan will route those connection to VIPs, node specific VIPs. The scan will not route the connection to node specific IPs. Scan will pass over that connection to node specific VIPs. And if these 14 users who are connected here, if this node goes down, since all these 14 users are connected to VIP via scan, they're connected to VIP. All these 14 connections are failed over to existing node. And with the help of scan, still they were able to achieve this failover scenarios. That's good. And then what about this node down situation? What that node down situation means? Assume that this node went down now and all the 14 connections went here. It become 114 now. And your client 5 comes, C5 connections comes and it go to scan, and your scan is already aware this node 1 went down, and your scan will never route the connection to node 1. Always scan will route the connection to node 2 now. And another 10 more connections comes. All those 10 connections will go to my node 2 only. Your scan is smart enough to know that which node is down, and scan will never route that connection to that node which is down. And assume that there's one more challenge here. That is, all these three activities are able to achieve by my scan. Sorry for that. Okay. These all three challenges, whatever we had, with the help of scan, I'm able to achieve. But there's one more challenges we had it any of these versions here. Let's understand that. Right here, when we had this node specific IPs, when we had this node specific VIPs, when we had the scan VIPs, what happens? Right now I'm having only 2 nodes, and then my organization is going and my business is going. I am planning to add 2 more nodes, 2 more cluster nodes, node 3 and node 4. We added 2 more node to my cluster. It become 4 node cluster. Then what you need to do? Again, challenging here. What was that challenge? Let's understand here. Right. When you are having this node specific IP in 9i and all, you need to reconfigure your entire application. You need to redistribute the scan TNS details, so not a scan, TNS details to all your end users. Right now it has only 2 nodes, and now we came up with 2 more nodes, and you have to inform all the end users. We added 2 more nodes to my cluster. Go ahead and then update your TNS details with these 2 more nodes. And if you have 1,000 connections, you have 1,000 users who are connecting through client. On all those 1,000 system machines, you have to rename, or you need to re-add this TNS file. That's one challenging. And if you configure your application with the JDBC and ODBC, all your application has to reconfigure with your new TNS details with the 2 nodes are added. That's one challenge. Manually, you need to edit all those end users, client machines where they're using the TNS file. You need to edit or modify all the TNS file with manually editing this TNS file, whatever the 2 nodes you added. And same thing goes to your VIP also. This is your old TNS files, and you have to go to all those thousands or hundreds of connections, all those end users, and you have to give those VIP names, 2 extra VIP what you added, 2 more node 3 VIP and node 4 VIP. Again, this is challenging here. And whereas in case of scan, there are no node specific IPs, there are no node specific VIP. It's just a single scan name, and you no need to add a node IPs, you no need to add a node VIPs. Whether you can add 2 more nodes or another 2 more nodes, or whether you delete the 2 more nodes, doesn't matter. You no need to modify anything on your client side. You no need to monitor, you no need to reconfigure your application. That's one of the advantages. Your node addition or node deletion or any modification in your cluster side, you no need to request your clients or application user to reconfigure with the modified TNS details. It's all about the scan. The moment you add 2 more node to your cluster, your scan is aware of that. Okay, right now I'm having 4 node in my cluster. And if you delete any one of the node, and your scan is automatically get to know, okay, I'm having only 3 node in my cluster. node addition or node deletion, everything will be dynamically handled by your scan, right? So which came in 11G, and that become a standard now. And then after that scan, there are no more changes in the networking side when it comes to RAC. And again, in 19C onwards, they started with something called, there are some more little bit changes in the networking side. They came up with something called, and again in 11G, they came up with HAIPs and all those things. So that's a little bit, again, advanced concept. But this is, fair enough now to understand why node IPs, why node VIPs, and why scan. The simple understanding is node IPs cannot able to handle the load balancing and cannot able to handle the your failover situation. Then Oracle came up with the VIPs to handle that failover situation, so that whatever the existing connection, they can easily fail over if they use a VIP, which is came in your 10G. And then still after that, the load balancing was not proper, and whenever extra node is added to my cluster or removed from my cluster, that situation become a tricky. They have to reach out to all those end users, modify the TNS details. That become a tedious job. And to overcome that, they came up with this scan, right? Uh, any questions so far or any concerns? Right. That's about your why node IP,
So,
why
excuse
node VIP.
me, Malik, how the listener will look like? This is TNS. So, how the listener could look like with
It's the
all these
same listener.
three?
There is no difference between your scan or whatever it is. Listener is remain same. There's no changes at all. Listener, whether it's a standalone, whether it's a rack, or whether it is a ASM with ASM, without ASM, your listener is same. No changes in the listener.
So, like for all the three versions, is there any change or same
Everything is
thing?
same. No changes at all.
Okay.
All right.
But why the port was used 1522 instead of
Whatever
1521? Is
port
there?
you can use, whatever port you want, you can use it.
Oh, there's no change. There's no any specific 1521, correct?
No
Oh,
restriction. You can use whatever port you want.
okay. Okay. Thank you.
Malik, how scan will know how many nodes are available?
That is your rack configuration. Your scan
Mhm.
is part of your cluster resource. Your scan will be running across all your cluster nodes. Your scan will be aware of that water node part of my cluster. You don't need
Could you
to.
show?
You don't need
Could
to
you show
go
like?
ahead. No, no. You don't need to check any configuration file. You don't need to show anything on that. Your scan is part of your cluster resource, and water nodes are part of my cluster. Scan will be aware of that. Each and every resource which is cluster resource will be aware of what are my cluster nodes.
Could you show? Could you show the TNS of scan how it look like?
TNS of scan.
Yeah, means scan name or something.
Yeah, this is scan. Whatever
That's
scan you define, you're gonna show it in the scan name here. Whatever you're
okay.
gonna
Scan.
define the scan in the networking side, that's your scan name. And scan
So
name is the
scan,
one you're gonna define it during the installation. Scan
is
name
it
is the
not like
one.
etc hosts? The scan is not available there. No.
It is not recommended to update anything on your etc host. Your scan name is the one which is going to define it in the part of installation process. When you're trying to set up this 2-node rack cluster, 3-node rack cluster, you're going to specify the scan name. And that scan name, you're going to define it on the networking side, and how many IPs you're going to add it into that scan name.
Is there any user connection limit on node?
No,
Okay, that will be managed by scan, right? We don't have to bother about it.
no.
So where do we get the scan name if you want to see that?
SRCTL config scan.
Oh, thank you.
Yes, Malik. If you have the 5-node rack, 3 scan IPs is enough.
3 is minimum needed. That's more than enough. You can go with 4, 5, 6, 7, 8, 9, 10, whatever you want.
Okay. For example, the scan one, it will be allocated to node 1 itself. By
Doesn't matter.
seeing it.
Your scan can run at an NF cluster node. Node 1, 2, 3, 4, 5, 6, 7. Your scan can run on any one.
Okay. Okay. But it is not. It is 3 IPs also. It's fine. But it's recommended also.
Right.
Yeah. Okay.
Scan is a service. Is a service or something like that.
It's a listener.
Scan. listener.
Yeah. Malik, when we require to increase the number of scan IP, I mean, any condition.
Doesn't required. 3 is more than enough. When you have 4 node cluster, 8 node cluster, 32 node cluster, 3 scan IPs are more than enough. You don't need to increase or you don't need to do anything on that.
Malik, if node is down, node eviction happened, how can we able to see what is where we can able
Again,
to
we
find
talked on that yesterday a little bit. Node eviction. Node eviction means node went down. Any one of your cluster node went down, and you need to go to that CRS logs and check for that node eviction reason. And I talked yesterday, node eviction basically happens because of network heartbeat or disk heartbeat. So any of these two reasons, your node eviction will happen. And main log you're going to check it out is your CSSD log, any one of the reason. Whether it's a node eviction happen due to network heartbeat, node eviction happen due to disk heartbeat. Again, what is network heartbeat? Node to node communication failed. What is disk heartbeat? Node to voting disk communication failed. Any one of these two reasons, your node eviction will going to happen. And the moment node eviction happens, you're going to check the CSSD log. Again, where is the CSSD log? Yesterday I showed you, right? You have to go to that CRSD trace directory and you have to check for the CSSD log. Along with that, you have to check for the node specific log and instance specific alert log. These 3 logs will give you what is the reason for node eviction.
How do we come to know it is an network error or disk error? Is there any ORA error for that?
No, in the CSSD log, you will get to know whether it's a network heartbeat or whether it is a disk heartbeat.
Okay, that's what, Malik. Is there any specific message that says network or disk?
In this log, CSSD.trc
Okay,
is a log. In that log, you can see that signature, whether it's a evicted due to network or whether evicted due to disk heartbeat.
Okay.
And then if it's a network heartbeat, then you need to work with the networking team. What had happened on that time? Is the node to node communication failed? Why it is failed? Whether the traffic is blocked or whether the packet dropped or whether it is a network firewall is blocking the connections between node to node. And you need to work with the networking team and find out what had happened on that time. And if it's a disk heartbeat failure and why the nodes is not able to reach to my voting disk. Is there any disk corruption or is there any disk controller is not good? Or is there any the connection between the your nodes to the disk? Is there any network delay in that? So again, you need to work with your Linux admin and understand that with a couple of OS logs, what had happened at that point when the node eviction happened. Right.
So what is the status of the other nodes when the one node is down and in the CSSD
It will be up and running. No issue in that. If the
and
node
we
goes
can
down,
okay, and we can start CRS and shut down. We can do those operations with that node which is down.
yes, you can do that.
It won't affect the other nodes. Okay.
Yep.
Okay.
Right.
Thank you.
Okay. Let's understand a little bit one more concept. ASM, we used to call ASM, or sometimes we used to call grid infrastructure. Sometimes we used to call clusterware. What are these things? ASM, grid infrastructure, clusterware. Why we need? Okay. Let's remove this. We have 2 nodes and we have this shared storage here, right? Your shared disk. And I'm going to store, this may be your NFS or this may be your ASM storage or anything. So you see that your database is running here. DevDB is your database which is running here. For this DevDB, what I'm going to do, I'm going to start my one instance here. I'm going to start one instance here. So for that, I'm going to start here. Say this is my DevDB instance 1 and this is my DevDB instance 2. I'm going to start 2 instances for the same database. All the data files are available here in this particular shared storage. Again, it may be your NFS SAN or network devices or ASM, anything. So in order to install this ASM, sorry, your database instance 1 and database instance 2, you need to install Oracle Home. And again, you need to install your Oracle Home here. You need to install Oracle Home on both the nodes. And on top of that Oracle Home, your instance will be running. Without Oracle Home, your instance will not run. That's the software needed. So you're going to install Oracle Home on node 1. You're going to run that instance 1. You're going to install Oracle Home on node 2, and you're going to run that instance 2. Both the instance are part of that same database, DevDB, which is on shared location. And these disks are mapped to all the nodes in my cluster. So this is a typical how the RAC database will act. And if you don't have ASM, right? If you don't have ASM disk group, will you be able to achieve this RAC database? Right? So what they used to do, they used to install something called ASM Home, right? And then ASM Home. On top of that ASM Home, they used to install create ASM instance 1 that will be start with always plus ASM 1. And on this ASM Home, they will start with ASM Home 2. So this ASM Home, whatever we're talking about now here, ASM Home 1 and ASM Home 2, earlier in 10G, what they used to do, what we used to do, we used to install two separate software here. This is in 11G, prior to 10G. Now it is a GI. GI stands for Grid Infrastructure. So what is this grid infrastructure and why we need to install? So prior to this grid infrastructure, we used to install ASM Home and Clusterware Home. So ASM Home to run the ASM instance, whatever this ASM instance 1 and ASM instance 2, and then on top of that ASM instance, we used to install separate software called Clusterware software. And the moment we install Clusterware software, it used to make these two nodes together a cluster of 2 nodes. And if you install this Clusterware on 4 nodes, all the 4 nodes combining together, it used to make it as a cluster. This was a tedious job. Prior to 10G, we used to install separate ASM Home and separate Clusterware Home and separate Oracle Home. We used to install 3 software, and ASM Home is to manage your ASM instances, and Clusterware Home is to manage or to form a clusterware of 2 node, 3 node, 4 node. And Oracle Home is to manage your Oracle instance. 3 software we used to install in 10G or prior to 10G. In 10G release 2, what Oracle has done, they combined all this ASM Home and Clusterware Home together, and they came up with something called Grid Infrastructure, one single software. Single software, and that they call it as a Grid Infrastructure, GI. So just install one software, GI software on node 1 and node 2, that is gonna act as your ASM Home, and as parallelly it's gonna act as your Clusterware software, and it will build the 2 node cluster or 4 node cluster wherever you're going to install. That's a simple understanding.
Only one home?
Only one home means?
Like a grid and a cluster and a ASM combinedly called only one grid home?
Right.
Okay.
So that was the idea when in prior to 10G release 2, to avoid this tedious job installing ASM Home separately and in creating ASM instances and installing the Clusterware software separately and making it as a cluster of 2 node, 3 node, and later installing the Oracle Home. So the TDS process, everything Oracle removed, and they combined all the ASM software and cluster software together and came up with a new single software that is called a grid software. And the moment we install, we call it as a grid infrastructure. So grid infrastructure, somebody asked what is grid infrastructure? Grid infrastructure is a combination of my ASM software plus Clusterware software. And Clusterware software will give you cluster features to making 2 node cluster, 3 node cluster. All the cluster functionality will be handled by the Clusterware software. And whatever the ASM Home to provide the feature to sustain my ASM instance. In order to run your ASM instance, you should have a particular Oracle home. ASM home is kind of your Oracle home, where in Oracle home, Oracle database instance will run. In the ASM home, ASM instance will run. Right, that's a background how that grid infrastructure came to provide your functionality of Clusterware and to provide the functionality of your ASM instance. Right. So this Clusterware will give you cluster software or cluster functionality, combining all the nodes as a cluster part of cluster, and will give you. And then why we need ASM instance, right? Cluster software, the moment you install your grid or separately you install your Clusterware, that will make 2-node cluster or 3-node cluster, and I'll get all the cluster features. And then why we need ASM? What ASM will help here? And if you don't want to use ASM, fair enough. You don't use ASM instances. You can shut down your ASM instance. Still, since you have Clusterware software and all the instances are running, and you can still form a cluster on the shared location here. You can use a NFS location, mount that NFS location on both the nodes, and you can still run your Clusterware here without your ASM instance. Your ASM instance is needed when it is needed. If you don't want to use your NFS shared drive, you want to use your ASM disk group. ASM will provide so many other advantages. Your mirroring, striping, ASM disk groups, and ACFS file system, and high disk reads and write outputs. All those features will be provided by this ASM instance. So if you use ASM instance, you can avoid the dependency on your NFS or your host or your network or your line storage admin. You can have your own storage. What ASM will do, combining all this disk, ASM will create something called DG, disk group. You may create a data disk group, or you can create a record disk group, or you can create whatever name you want, or you can create your FRA disk group, or you can create your control disk group. Whatever the disk group name you want, combining disk 1, 2, make it data. Combining disk 2 and 3 and 4, make it reco. And create your own disk groups with help of this ASM instances. And you can put all the database specific data files, redo log files, your archive log files, control files into your ASM disk group, so that you no need to depending upon your NFS storage or your storage admin. You can manage your all the disks, all the storage, whatever you want it. Right?
So
That
all are in binary forms, excuse me, all are in binary files, or like
it's all
anything we
binary
can,
file. Everything is binary.
okay. So, okay.
Right.
So
So you
like
can
where
put all
we
of
have
all
SP
of these
file and,
files. No, I'll come to that point. You put all of
okay.
these files into a disk group. And if any of these database instances to read and write my data files, it has to read and write from the disk group, and your ASM will act as a mediator. Whenever database instances, like users are connected to my database instance 1, he's trying to read and write my data files. Your ASM will allow that end user connection to disk groups, and your end users are trying to read and write the data from the disk groups. That will be much more faster than reading and writing from your NFS mount point or the OS disks, because your ASM disk groups has a high reads and writes, and it has its own built-in mirroring striping, and it has its own ACFS file system functionality. All will be provided by this ASM instance. So because of that, it's one of the best recommendations, or Oracle strongly recommends to use always ASM disk groups when it comes to RAC, when it comes to Clusterware. Don't use any of the NFS mount points. Even if you use NFS mount point, you have to depending on your OS admin, you have to depending upon your storage admin, and they have to do your mirroring, striping, and disk reads and writes. But whereas in disk groups, you no need to depending upon your storage admin or OS admin. We are the one who is going to manage your all the disk groups. Whenever the disk group is full, we're going to add the disk. Your OS admin add the disk into your OS side. We're going to do the formatting and adding into the disk group. We're going to increase the space, or whenever any disk performance issue here, we're going to ask OS admin to remove the disk, and we'll add the new disk by your OS admin, and we'll format it inside my disk group. Right? The dependency on your storage admin and OS admin will be reduced here. And at the same times, your ASM will give you better performance in terms of reads and writes, and in terms of mirroring, striping, and whatever the reasons, whatever the features it has. Right? Let's quickly check on my lab here. Right, so we have ASM on node 1. Grab S1, and we have ASM2 on node 2. As we draw here, we need ASM1 and ASM2. Instances are mandatory to provide your ASM storage. And this ASM1 and ASM2 are running on ASM home. So you can call it as a.
Okay, what is this plus sign indicates? Why that plus is needed?
Plus is not a database instance, it's a ASM instance. Without plus,
So
it's
plus
act as a database instance.
with plus.
What, hello.
Yeah.
What ASM instance contains like database instance? How it is different from this?
If it's a plus, ASM instance. If no plus, it's a database instance.
No, in database instance like SGA part and
Same
what
thing.
is
Whatever instance means what? Just go back to your basics. Instance means what? Memory plus background process. And your ASM instance, ASM also instance, it has the memory plus background process. And what are the background process? DB writer, log writer, check pointer, and whatever you will see that mandatory background process, everything will be available for your ASM instance. What are the memory components? Your SGA, PGA, your shared pool, DB buffer cache, redo buffer cache, whatever. Just stick to basics. Instance means memory plus background process. Memory means we know already SGA, PGA, background process. We know all the mandatory and non-mandatory background process. Whether it's a ASM instance, database instance, everything should be available. Whether it's a used or not used, doesn't matter. The moment you start
So
ASM instance or database instance, all the memory component, all the background processes are available. It should be available. Whether it is a used or not used, that's the second part.
So instance, we need to start up or shut down separately for each instance, or is there any way like
Whatever you
all
want,
four
you can do. You want to shut down startup and do it on one node, do it on separate node, do it on ASM level, do it on database level. You can do whatever you want.
So I can stop the instance of one from my node 2 also, correct?
I explained yesterday, right? From node 1,
yeah.
you can start it on node 2. You can node 2, you can start on the node 1. It's all
Okay.
clusterware. You can manage it from any node on that node or from the remote node, or you can do it at ASM instance level. You can do it at database instance level. Everything you can do it.
Okay, we should shut it down and start up like SRVCTL start like whatever the instance name. So like that. Yeah. Okay. Thank you. Yeah. Sure.
So Malik, the one question, the difference between cluster and grid is like grid is combination of ASM plus cluster, and cluster is just only for, I mean, cluster configuration, correct? I mean,
Right.
thank you.
Right. If you just
With the
observe here.
connections,
Yeah, please go ahead.
hello,
Go,
when the
go ahead. Yeah, go ahead.
client connections will be first come to a ASM instance or Linux.
Client connection will come to your scan, and via scan it will go to your database instance. It will never go to your ASM instance.
Okay.
Right. Your ASM instance, and you can observe your pmon, db log writer, check pointer, all the background processes. But whether it is going to use it, that's the second part we'll discuss in later. Right. Instance means you just understand, go back or stick to your basics, memory plus background process. You can see your ASM instance, all the background process, whatever needed for my instance.
So what happens if I shut down ASM instance from one node? Can I do that?
Yeah, you can do that.
So is there any, will it affect any of these,
Yes, it'll affect.
any other databases? Or,
It'll affect.
okay. So we
Like
will never
we'll
do
come
the,
to we'll come back to that point in a minute. Give me a
Oh.
second. Your database instance, again, all the whatever background process needed for database, same background process. And again, we'll discuss in furthermore once we start. We have a pmon for my database. We have a pmon for my ASM. Whether the pmon is really used here, we have a DB writer here. You have check pointer here, log writer, check pointer on my ASM. Are we going to use these processes or not? If we use it, on what scenario we are going to use it? So all this we'll talk in further more details. But whatever the mandatory background process needed for my instance, irrespective of whether it's a ASM instance or whether the database instance, it will be available. And coming back to the same memory, whether it's the database instance or ASM instance, all your memory component should be available and it should be there. And whether it's used or not used, we'll deep dive and we'll discuss later. That's one part. And now, GI software I talked. GI software is a combination of ASM software and cluster software. Combining together, we're going to install the GI software. So one way to validate your GI software, just do ps-ef, grep smon. That's going to give you the default GI home location, or you can do pmon. You can pmon will not show. Smon is going to show you one default grid location, or you can do ps-ef grep d.bin. That's going to give you the GI grid infrastructure software wherever you install, and all the cluster specific daemons or cluster specific services which are running here. So this is your grid software.
So PS minus EF smon gives only for the grid infrastructure items, because PS minus EF grep pmon will give you the
Doesn't
database is
matter.
running.
Doesn't matter. Right. So you're going to do ls. This is your software where you installed your grid software. So in order to get the clusterware detail,
Malik, for entire course, this link only, or other link you have to provide? You are going to provide other link, or
there's other separate link. This is the demo classes. It's not a publicly available. It's only for registered student. They will get other link. Right. This is your software where you install your grid infrastructure. Use your own app 19C grid. Right. You can call this one as a ASM software, grid infrastructure, or clusterware. Anything nowadays, any people call it as the ASM software or ASM home. You can say ASM software or ASM home.
like here also we need to.
ASM software, ASM home, and GI grid infrastructure or clusterware, or simply you can call it as a GI software. So you can call it as any one of your colleagues or anybody talked any one of these, they're referring to your grid. Again, grid means your ASM software plus cluster software. So this is location. You can simply go ahead and then check ps-ef grep d.bin. So that's going to be give you all the cluster daemons. All will start from your grid software bin, and all
Here
the
also we need to create databases, right?
right. So this is your clusterware software. Right. We installed clusterware software. That's a grid software, nothing but grid software, and ASM instance is running on that. And at the same time, we'll install later once we set up my grid and clusterware, and we'll install Oracle software, and we'll start my database instances. You can cat etc tab. That is my ASM instance. User on app. Okay, it's wrongly added. If somebody look at this one, user on app Oracle product 19c, it's a wrong. This update, whatever they made it, it's a wrong. Class etc tab. And I'm going to modify that one. ASM instance to user on app 19c grid 19.0.0.0 and grid. So this is my grid software now, where I installed my clusterware and ASM software, and this is my Oracle home. This is my Oracle software where I installed my Oracle database. Right. So GI software is a separate software. Oracle software is a separate software. We're going to download it and install it.
Malik, I have one doubt.
Yeah.
Here also we need to install databases, right?
No, on grid we don't install databases.
For RAC installation and all we need to do, right?
On the Oracle software, we're going to install it over here. Right. Let's go to let's go to Oracle home and see what software it is there. Same concept, same whatever software you're going to install, all the software will be available inside your Oracle home. And whatever you install on grid, will be grid software here. Two separate software we're going to install in order to form your 2-node, 3-node, 4-node cluster. That's one thing. The JS software is the different and Oracle software is the different. With the JS software, we're going to achieve ASM instance and Clusterware. And with the Oracle software, we're going to set up my Oracle databases. And all the Oracle instance will run from Oracle Home. All the cluster services and all the ASM instances run from Grid Oracle Home or the Grid Home.
And the actual database is stored in the ASM disks.
It's on your disk groups, ASM disk groups.
So when we add or delete any data file, so we need to go to ASM or Oracle.
Inside your Oracle SQL Plus.
Oh, just log into SQL Plus and just add a data file to the disk group.
Right.
Oh, table spaces and everything.
Right. Right now, coming back, one more concept, CRD files we can call it as. Right, let's go back here. Many people will use CRD, CRDF and all. The CRD files, they will call it as CRD files. That is meaning control file, redo log files and data files. Let's understand a little bit here. You have node 1 and you have node 2, two nodes. And in this, you have ASM home, where your ASM plus ASM1 will be running here. And the same thing, you're going to install ASM home on node 2 and where your ASM2 will be running here. Right. And on top of this, you have Oracle home on node 1 and Oracle home on your node 2. And where you are having DevDB instance 1 will be running here. DevDB instance 2 will be running on your Oracle home. And in order to create this particular database, we have certain mandatory files, or some of them are non-mandatory files. And what are those? And we'll understand here now. Let's see, we'll go back here. And what I'll do now, I'll just remove this one. Okay, I'll not remove. Let's understand one by one. I'll talk about, for this DevDB, I have something called system.dbf, my system data files. I have my sysox.dbf. I have my undo.dbf. Let's move it here. System data file, sysox data files, undo and temp. So just mandatory data files, I'm going to take it here. Let's keep undo aside. Your system, sysox, temp are all shared. So you're going to have a common file system for your instance 1 and instance 2. Right, your instance 1 is also pointing to the same set of data files. Your instance 2 also pointing to same set of data files. And whereas when it comes to undo, there's a separate data files for undo. Let's go here. We have undo data file 1 and we have a undo data file 2 separately for each instances. This instance has a separate set of data files undo, and this instance has a separate set of data files undo 2. That's one difference. And the second difference, I have my redo logs separately for my instance 1, and I have my redo logs separately for my instance 2. That's a second difference. And then I have my common password file for both the instance. Instance 1 and instance 2 should have a common password file. And I have a common SP file for my instance 1 and instance 2. Both are having a common password file. And having said that, I can have common SP file, and also I can have local SP file for both the instances. I can simply put one password file and one SP file for both instances. There's no hard and specific rule. Ideally, best practice or best recommendations, use a common password file and common SP file on the shared disk group, or you can have your own password file here on your node 2 and you can have it on node 1. That's also possible. You can have your own P file on node 2 and you can have your own P file on your node 1, and this P file internally point to your SP file. That also you can have it. No restriction, you can do
So
that one.
if you have P1 and P2 are separated in two machines, and if you change any parameter, so P1 affect.
What I'm trying to say, put a P1 file and put a P1 file and to put a P2 file and internally point them to SP file. Doesn't matter whether you're going to change it on node 1 or node 2, you're going to change it on SP file. Don't use a local P file. If you want to use a local P file, that local P file has to point to SP file, which is inside your disk group. And if it is not having any SP file inside disk group, then you are not serving the purpose of your clusterware. Right? That's
The
possible.
SP file is unique. SP file is unique, and P file can be multiple, different.
Right.
Loads.
Right.
Okay.
Common temp file also.
Common temp file, yes.
So in the case of this group, if you create these groups, how do you manage? You still have to separate them.
This group of what?
In the ASM home, if you
Right.
create these groups like you were talking about, you can create this group for redo log, and
You can see,
create this group.
right, I'm gonna show you that one. Right now, what happens? Let's connect to my database ps-ef grep smon, and I'm gonna connect node instance node 2. That again, this suffix indicates your node number. Right now, I'm at host node 2, and it'll be having this suffix here node 2. I'll go to node 1. Anywhere node 1 or node 2, anything is fine. I'm just gonna run .vorinv. I'll set the environment to devdb1, and I'm gonna connect to my database instance. Select name from $v data file. So you have your system, sysocs, undo, undo1, undo2 users. So all these files coming from your data disk group. The whatever you are seeing plus here indicates your ASM and ASM disk groups. So all are coming from your disk groups. And the moment you do select name from $v control file, you have data and reco, and which are coming from one control file is coming from data and one control file is coming from reco. Select member from $v log file. So you have one, you can see redo log group 1, redo log group 1, 2 files, redo log group 2, 2 files, redo log group 3, 2 files, redo log group 4, 2 files. One is from thread 1 and one is from thread 2. One is coming from data and one is coming from reco. So while creation of your database, you want your data files to be on the data disk group. I want my control file should be on the /control disk group. I want my redo log should be on the reco or /redo or plus redo disk group. You can define it. You can do any customization at the time of when you create your database. You can move all your data files to different disk group. This is one way. Connect to your database and validate where all your data files are sitting. That's one way.
So can we go with the $GV or $V?
It depends what you are doing, what you are trying to achieve.
So here we can see $V means it is the for one node.
Again, $V has a separate indication. We'll talk later. That is one way. You want to validate all your cluster data files and all. You can connect to that respective database and validate it. Where are your data files? Where are your control files? Where are your redo log files? Where are your password file, SP file? All those you can validate. And other way, how I can go to this particular disk group? One way is you can go to ASM. You can set the environment to your ASM. Connect SQL plus /s sys ASM. So when you're connecting to your database, you'll connect it as a sys DBA. But when you're connecting to your ASM, you're going to connect it as a sys ASM. Once you connect to your sys ASM, describe $v disk group. describe right 1 second. Right. So one way, okay, I'll come to this point. Let's go to ASM CMD. So you can go to, or else like, let's connect back to that one. Describe $, ASM underscore disk group. So select name or group number, comma, name. I'm just going to take only 2 columns as of now. You're going to see disk group number 1, 2, 3. I have data, OCR, and RAC, 3 disk group. You can, one way to manage your disk groups is by connecting SQL Plus as ASM by sourcing the environment to ASM. That's one way. Or you can go to ASM CMD, ASM command line, which will be ASM command line command prompt. LSDG, list disk group. List disk group will give you whatever the available list group in your environment right now. That's small it. Right. You have a data, OCR, and RAC, and how much size is used, how much total available, how much is free, how much is usable. All those things you can manage it over here in the ASM command line, and you can add a disk and you can stop a disk group, whatever you can do it from here, or you can do it from SQL command line. That is at your ASM side. Again, a lot of things you can do it, adding a disk, dropping a disk, creating a new disk group. Right now I am having data, OCR, and RAC. You can create one more disk group like control, FRA, or redo logs, all those disk group. You can add a multiple disk into your clusterware nodes, and you can create multiple disk groups to store your different redo log files, control files, and other things. Right. Any questions so far?
So how can I see my data files? Same ASM command.
You already saw here, right? On your database side, this is my location. I can go inside that CD, go to that location, ls-l, all your data files of your database. Right. So this is your PWD data, DevDB data file. You have to connect to database and get your data file location, select name from $, data file, and you have to go to that respective data file and check for the redo logs of the data files. If I can go to control file here, CD, control file, ls-l, this is my control file. And if I can go to my redo log groups here, ls-l, and these are my redo logs. All right. Any more questions here before I jump into the next topic?
Malik, could you please log into ASM instance? I just want to check the status of it, whether it is in mount or no mount.
Right.
Select open underscore mode from $, ASM underscore
Underscore
instance. ASM instance or a $, ASM. Yeah, $, instance. No, it should be $, ASM underscore instance. I just want to check the status of ASM instance.
instance underscore name, comma, status from
ASM is always mounted.
Okay. Will this instance, I mean, ASM instance be started or mounted? I think it should be in mount.
Started.
It will always be in started mode.
Always be in started mode. Just go back to basics, guys. Let's understand your little bit of startup sequence. Your database has a shutdown, and it has a no mount, and it has a mount, and it has an open. So these are your database startup sequence. From shutdown to no mount, you need a SP file. And from no mount to mount, you need a control file. Right. And then from the mount to open, you need a data file. Right. Your ASM is just an instance. It will not be having control file. It will not be having any data file. And your ASM instance will never go to mount mode. It will never go to open mode. Your ASM instance will always be in started mode, which will be of no mount mode, because it has only SP file and it does not have any control file. Who has a control file? Only your database has a control file. If you have a control file, you can go up to mount mode. Your ASM will never go to mount mode.
So some instance is not having any problem. So we need to just check only the SP files only.
Yep.
Malik, as you told, I mean, undo table space are different in all the instances, correct?
Right.
So in case we need to add a data file in your undo table space, so we need to define a specific thread, correct?
Right.
I mean,
that's correct.
okay.
So can you show me just adding one data file to one table space?
Yep, you can do that. Right, we'll show you in a little bit.
What
later.
are the main parameters in ASM file?
Main parameters. You don't need to define any parameter in that. You just need a disk group names inside your ASM SP file.
Only one parameter is required.
Yeah, disk group is only one parameter is mandatory.
I think rebalance and all those are also, I think, defined sometimes.
You can define it online. You can define it. It's all on-fly parameters. Your ASM instance to start, it does not need any parameter.
This group name, right?
Right. All right.
So ASM SP file is separate, is different from normal Oracle SP file.
Right. SRVCTL config ASM. .inv devdb1 plus devdb1 srvctl config database -d devdb. Right, so your devdb, I'll just take only this much. Your ASM has its own password file, OCR, and your ASM. This is your ASM password file. And that's the backup of that password file. And I don't need this. That's one thing. And you can do .inv plus ASM1 SQL plus /sysasm. To connect to ASM, always use sysasm. Show parameter SP file. Put SP file also.
Which password is stored in ASM password file?
ASM password.
ASM password.
Yeah.
So is this different from the database password file?
Right.
Means database sys password file.
Right, that's correct. Right. Your
So in both ASM, I mean the same password file, correct? I mean.
Right. It will be coming from, again, go back here. Your password file will be common. It is not advisable to store the local password file. And your SP file, it should be common. That's the best practice. And if you want to store the local P file, and you can point that local P file to point to SP file. That's possible. But password file, keep it as a commonly stored on your disk group.
And alert log file is also node specific, I believe.
Everything is node specific. Whatever the processes, whatever the files, it's all node specific.
Password file is generally stored in Oracle Home DBS location, not in disk group. I think
it should be on the disk group.
In database password file.
That's a 11G. We used to have it under DBS location. ASM password file, database password file, everything under DBS location. Starting with the 12C, everything is stored under DBS. So everything is stored under your disk groups.
And the alert log file is on.
Again, what we're talking about is a database specific files. If you talk about alert log specific data files, PMON specific data file, trace files, SMON specific trace file, and whatever you talk about, it's instance specific. What we're talking about is a database specific. Whatever comes to database specific is a shared one. Whatever comes to instance specific is a node specific. Your database instance alert log, database instance alert log, your PMON trace file, your PMON trace file, your smount trace file, your smount trace file, your db trace file, your db trace file. Whatever you talk instance specific, that will be on the node. Whatever we are talking is a database specific parameters or database specific files. These are your data files, which are common between both instances. Your password file is common between both instances. SP file common between both instances. But when it comes to redo logs and undo, it's a instance specific, but still we're going to store it on the disk group. And when it comes to again redo logs and undo, it's a instance specific. And on top of that, when it comes to archive logs, again, it's a common between both the instances. Your redo logs also generate archive logs. Your redo log of instance to also generate the archive logs. Again, those are common to your database. Right. Let's go back here. What we're talking. Your ASM password file is again on ASM disk group, and your Oracle database password file is again under your disk group. And your SP file for your ASM instance is again on disk group, and SP file for your database again on disk group. That's how your configuration will work. Right. Let's execute and we'll see little bit of
1 second. You say, excuse me, if you SRVCTL config database -d, when you say devdb, so I see devdb1 and devdb2. Like, what is the, because in every node, it is one node one shows
-d
one.
is a database, not an instance. 1 and 2 are your
Okay.
instances. Again, go back to my diagram. 1 and 2 are instances. Your devdb is a DB name, and devdb1 and devdb2 are your instances. Instance name is different and DB name is different. I'm using -d is for my database.
So whenever I see any for the databases, only node 1 and 2, only the database name. That's it.
Yep.
Okay. The DB1 and DB2 are for the instance purpose.
Yep.
Okay.
All right.
Thank you.
Any questions so far? Right. Now, if you want to shut down your database, right now you have 2 nodes and 2 databases we're running. I can quickly show a couple of commands for my database. devdb1 srvctl status database -d devdb. So it's going to give you all the cluster database instance, devdb1, devdb2 running on node 1 and node 2. Both the instances are running on this for this database on both the nodes. This is one command, what you're going to check your database status. And instead of status, if you make it stop, it's going to stop both instances on all the nodes. And instead of stop, if you make it start, it's going to start your instances on all the nodes. I don't want to do stop and start of entire database. It means all the instances. I want to do only one specific instances. srvctl stop, and you want to stop database or you want to stop instances? I want to stop instances. srvctl stop instance. I want to stop my instance -i. I is instance. I want to stop my instance 1. I can run it on any node, node 1 or node 2, doesn't matter. Instance 1 of which database? Of my devdb. I can run this one on any node, or I can run this one on any node. It doesn't matter. You can run it on node 1 or node 2. You can run it from anywhere. Stop the instance 1, stop the instance 2 from any node. And the same thing goes to start instance 1, start instance 2. You can run it from any cluster only. You have 8 node cluster, you can run it from any node. You're going to stop only that particular instance, what you're going to specify here.
So when you say stop and start, if I want to start, start immediate.
It's always stop immediate and start normal. And if you want to do that specific, you have to -o, what you want, mount, no mount, start in shutdown abort. You can do whatever. When stopping it, you can use -o, shutdown immediate, normal, transactional. You want to start it in immediate, all these things, shutdown immediate, startup mount, no mount, open. -o is a keyword, you have to use that one. You want to stop your database with what? -o, shutdown abort, shutdown immediate, shutdown transactional. -o is a keyword. You have to use this. You want to start the database or start the instance in which mode? -no mount, -mount, -open. You have to use this - keyword when you are opening the database or shutting down the database.
So when you shut down the main database, so both the instances will automatically shut down, correct?
Right.
-o option is used in database level or instance. It is used in only database level options.
Anywhere you can use it.
So,
This -o on here instance level or DB level, anywhere you can use.
But
so if you shut down, okay, if you shut down and start up, so what about the cluster? Any?
I'm going to talk about only database instance. Your cluster will be up and running. There won't be any impact at your cluster side. Right. Same thing, you can do it for your ASM instance. SRCTL status, what you can do, SRCTL status, instead of that, SRCTL stop. I'm just going to do directly SRCTL stop ASM, or you can just do plus ASM or, okay, before that ASM, let's go here. .inv plus ASM CRSCTL stat resource -t. So -t -init. So you have your cluster resource here, and one thing what you need to understand, we talked here ASM home and database home and my GI. This GI is combination of ASM and cluster. So the dependency goes like this. Let's put it over here. Cluster, and you can say that is CRS. On top of that, your ASM. On top of that, your DB. So this is your dependency here. What happened? Okay, your database here and ASM and Clusterware. When you stop your database, your DB will go down, your Clusterware and your ASM will be up and running. Right? This is a dependency. On top of your Clusterware, your ASM will be running. On top of ASM, your database will be running. The moment you do whatever command I just showed you here, stop database or stop database instance, you're going to deal with only database level. It will stop your database. When you stop your ASM, what happens? Your ASM, on top of ASM, your database is running. If your database ASM instance is not available, what happened to your database? The moment you stop your ASM, your DB will go down. That's the dependency. In order to run your database, your ASM has to run. Right? You can independently start and stop your database, but still Clusterware and ASM will be up and running. But if you want to do stop and start of your ASM, the moment you stop your ASM, your DB will go down. That's for sure, because without ASM, your DB will not run. And if you stop your Clusterware, automatically your ASM and DB will go down, because in order to run your ASM, in order to run your database, your Clusterware should be mandatory. If you do stop CRS, your ASM and database, everything will go down. All the services, everything will go down. Right? That's a dependency you should understand.
So when you start up the database, you just have to start up the listeners again, or just?
No, it depends upon how you configured. Whether you configured listener on cluster side, you're gonna come up with your cluster. CRS-CTL, stop CRS, CRS-CTL, start CRS. So you can start and stop your Clusterware, right? So you can do whatever you want it. At your cluster side, you can do start, stop, whatever you want. And then when your Clusterware is started, that's a least dependency. Means like it's the core dependency. If your Clusterware itself is not available, all your databases, all your instances, all your listener, everything will be like down. You cannot run any of your database instance or listener, or everything will be down, because that's a main dependency.
So Malik, if we will use the CRCTL stop CRS, so that will be also a graceful shutdown for database, or I mean, we need to first stop
Yeah,
database.
it's a graceful shutdown.
Okay.
Right.
So one command is good enough to shut down the entire cluster.
Yes, you can always use CRCTL stop CRS and start CRS. Again, you can go back to the same what I just explained, your CRS and followed by your dependency ASM, followed by your dependency DB. So this is a dependency. If you understand this dependency perfectly, so either you want to do a DB down, you want to do a ASM down, or whether you want to do a CRS down. You can do a CRS down and start and up. You can do stop and start of your ASM, and you can do stop and start of your database, whatever you want. Right. So this dependency will help us always whenever you are bringing that entire node down. In my case, I want to do this entire node down. I want to do some OS patching here. I want to bring down here. How I can do bring down of my entire services here on node 1. I can stop my database. I can stop my ASM. I can stop my CRS. Or directly I can stop my CRS. Everything will be down. Right. And assuming that I'm doing patching of my database 1 only. So I can stop only my database here. I don't stop my CRS and ASM. Why should I stop it? Right. Right. Any questions so far on the
So
cluster?
if I start and stop CRS, so I don't need to, because I see the startup sequence has database and NLS nodes and all these. So we don't need to do it separately. So automatically everything gets started.
Right.
If you say CRS CTL or start CRS.
Right.
And
Okay. So
using all, we can stop all the, I mean, stop the cluster in all nodes, correct?
That will not work. There's some flaw in that. We'll talk later on that. So there's a CRCTL stop cluster all. CRCTL stop.
What is the user we can use to stop and start the CRS?
It will be root.
Root only.
Right.
So sudo minus Oracle will do the root facility for the Oracle CRS CTL.
Depends.
If I write.
Depend on your Linux admin. If they have a sudo access to Oracle, you can do that. Otherwise, you have to.
Yeah, I could do sudo. Sudo means root, right? I mean going to root only, right?
Right. That
yeah, I have the access, but I have not given any root access.
Your Linux admin has to configure that one sudo access. If you are not configured, you cannot do it.
Yeah, I don't have root, but I have given the sudo. If I say sudo, I'm getting, but I'm not getting the root prompt. It is just $1 again.
Yeah. All right. Any more questions on this?
Malik, like what is the difference between CRS, CTL, stop CRS and cluster-all?
Cluster-all will do it on all the nodes. When you're doing a downtime on all the nodes, you're going to use this cluster-all.
So CRS, CTL, CRS means it's only one node can be down.
Yeah.
Oh, the other nodes
whatever I'm talking here, it's a node specific. Whatever I'm talking here, it's a entire cluster, like all the nodes.
So when you say CRS, CTL stop CRS cluster in one node, so that one node will stop the instance, not the database, correct?
Come again.
If you say CRS, CTL stop CRS for one node, I want to do that, and so when I give that command, so it stops the entire day CRS and ASM for that particular instance.
That particular node.
For a particular node, yeah.
Yep.
And no other. So if I want to do the entire cluster, I would do minus all is the thing, but that's correct.
Yep.
Or if I don't do minus all, it will execute. So on the wherever I execute on the same node, it gets executed.
It will be keyword CRS. It will be keyword cluster here. That's the difference.
Hello, Malik. How will RML will work on a Clusterware?
Doesn't matter whether your database is running on ASM or whether running standalone, whether it's a RAC, whichever node you're going to connect, your RMN will take a backup from there. DevDB1, I'm connected to node 1, RMN target / I connected to my RMN, and then I can run my database backup from node 1. If I run the same command on the other node, target slash, so I connected to node 1, instance 1, I'll take my DB backup here. If I can go to node 2, DevDB2, sorry, node 2, DevDB2, and rman target slash, I can take a backup from second node. It left to you where you're going to take a backup.
Can you graphically explain that? Graphically explain that? The RMAN part? Yeah,
RMAN doesn't matter, right? You are going to connect to RMAN here, instance 1. You're going to pull the backups, whatever the data files, you're going to pull the backup to node 1. If you connected RMAN on node 2, it's going to connect to your database and it will pull all the data file backups.
Okay.
Right? RMAN, you're going to connect to instance, not the database.
Can we use a common RMAN file to take a backup of 2 nodes?
You don't need to take it on both nodes. You can take only one node. You're going to take what you're going to take a backup. You're going to take a backup of your system, undo, temp file, password file, and
common
all.
files.
So you can take it from node 1 or node 2. It's left to you.
Okay.
SRVCTL command can be used from Oracle user, and CRSCTL can be used by.
There is no
root
specific
user.
rule on that. There are some scenario we can use Oracle user, some scenario we can use grid user, some scenario we can use root user. Based upon what activity you are doing it, it will come into picture. For example, if I can go here, dot var inv plus ASM 1 CRSCTL stat resource -t. I can run this CRSCTL stat resource -t. I can run the same command with Oracle user and I can exit and I can run the same command CRSCTL stat resource from root user. So it depends upon what activity you're doing and that you have to practice and then you'll get to know when to use a root user, when to use a Oracle user, when to use a grid user. And yeah, that all comes under practice and you have to do that.
Based on the activities. Okay.
All right. Right. Any more questions, guys, before we stop it for today?
So for archive backup files, always I get this archive files. So failure and what. So we do in the RMAN command only we need to take. Is there any separate way they are taking
RMAN
archive files?
RMAN
archive files. Okay. Okay.
All right. Any more questions?
Thank you.
So Malik, I have one question. Like, suppose if you want to install 2-node RAC in our personal laptop, so minimum how much memory is required for that?
If you are having SSD, 100 GB SSD and 16 GB RAM is more than enough. And if you don't have SSD, then at least you should have 24 GB RAM and 100 GB HDD.
Okay. So I have 8 GB RAM. So will it be possible to configure 2-node RAC?
8 GB, no.
Oh, okay.
All right. Any more questions, guys, on the course or any topic you want to talk?
Yeah, last question from my end anyway. So I have a listener and the listener doesn't show me the database, but the port is connected as a 1521 in the listener file. So what could be the why that?
No, you cannot directly get into the solution on that. You have to check for the listener log. You have to check for the services what are configured. Without that, you have to send a snippet. Then we can figure it out. Directly, we cannot get into the conclusion. All right.
Hello, Malik. This is Femi. I would like to take this offline. I'll be pinging you after this meeting, just to let you know.
Please.
Thank you.
Malik, my question is regarding for next week. I mean, when we will get the access on the Google Drive and how we, I mean, the links for join the meeting for next week as I submitted the.
You can ping me on my WhatsApp number. I can get in touch with that.
Okay, sure.
All right.
And how to how should I pay? How should I pay that? To start with, because I want to.
Ping me on my WhatsApp number. I can get in touch with that.
Yeah. So the details so that I can. Okay. Thank you.
Hi, Malik, actually,
Can you put the WhatsApp number on your in the chat here?
I can ping that one. Yeah.
Malik, if you have a number of databases in that cluster, so the storage will be shared among the disk groups.
Yes, give me a second. Right, I said my WhatsApp number in the chat. You can take a note of that. Yeah, you have a data disk group. You can create DevDB1, DevDB2, DevDB3, TestDB1, TestDB2. You can go with the UAT, prod. There's no limitation. With a single disk group, you can create a number of databases.
So there are 10 databases in my one node. If I shut down the ASM instance, so all will get affected.
Right.
So okay, okay.
Malik, I want to continue this RAC also. So
Right.
it's fine.
We'll ping you in WhatsApp. Yeah, ping me in WhatsApp. We'll talk that.
Yesterday I have pinged you, but you didn't respond. That's why.
Right. I'll ping you back. Yeah.
Okay.
Yeah, same to me also. You didn't respond. Maybe probably you're busy or something.
Yeah. Just ping your name. Probably I can.
Malik, I have one doubt. Actually, we are doing patching, right? For us, you did 344 patching. In that.
No, we'll talk it offline. Probably we'll take it offline. Any
Only 1
questions
minute.
so far? Any questions?
Only 1 minute. 344 patching is not there means which number I have to download 325 that only.
Now again, nobody knows about what is patching here. We never talked on that. We'll talk it offline. Yeah. Any questions so far on this course or anything you want to know or any question specific to this, whatever we covered?
So
Please.
in case of any emergency, if I have to contact you, so is there any good time or like what is that could be?
No, we have a WhatsApp group and you can post
Okay.
it anytime on the WhatsApp group, right? And then we'll.
Okay, because we are the EST time, suppose when I give it today, you may not get, until next day.
Anyone, right? Not necessarily me, anyone. If you have a struck and any queries, if you ping on the group, anyone can respond to that. Or if nobody is responding, I'll be there to respond you back.
Excellent. Thank you.
So Malik, if I enroll for weekly classes and if any classes miss, so can I join the classes which is daily classes? Can I join that one?
Again, as I said, it's a one-time registration fees. Once you make it, you can attend it next time. But you should give a reason that you are not able to continue because of so and so reason. Not my health is not good. I'm not able to continue this time, and due to my health condition, or I'm traveling abroad, or my parent, I'm going to hometown. Any of the genuine reason, if you have it and you're not able to continue, fair enough. And whenever I'm starting the same RAC batch, and you can get in touch with me, and then I can add you to that new batch. You can start it from the scratch. You don't need to pay any extra amount on that.
Okay.
So you're starting any database also apart from RAC?
It'll be this month end. We'll be starting the database course.
Only the database, right?
Yep, core DBA.
So that will be for weekend, or
it's a weekdays.
Okay, weekdays.
Malik,
What will be timing?
You are going to teach Golden Gateway also?
No, not yet. Not at this moment.
And any planning for performance tuning related? Classes.
No, as of now.
So for the database classes, what could be the timings in a day?
I'll ping you offline. You can ping me on my WhatsApp.
Hello, Malik ji.
Yep.
Hello.
Yeah, please go ahead.
Hello. I want to join this batch, but I want to know, can I get access of basics database videos on your Google Drive? Because some are confused.
Yes, you can get it.
Okay.
Malik.
Yep.
Malik, do you also give classes for Exadata?
No, not at the moment.
All right. For the Golden Gate, if say some people which have attended your database classes plus this RAC, if they want to have extra classes for you to teach Golden Gate and pay extra. Will you be available for that?
No, again, like as of now, we're not teaching any extra classes. Again, if it is scheduled or planned from my side, I'm definitely inform or intimate everyone. We'll have it. But right now, we're not taking any classes apart from this RAC and Code EBA.
So Malik, if any future plans, so you will update the same thing in your YouTube channel, correct? Also,
right.
Okay, thank you.
Right.
Malik, I have one doubt. Who are continuing Oracle DB and RAC? You are going to give some discount. Some others are saying like that.
We'll talk offline. Probably you can ping me on that.
Okay. Thank you.
I
Right,
am from
guys.
old batch student. Can you please add me in the new group?
Right, I'll do that. All right, guys. Let's stop it for now. We'll continue from the next week onwards. We'll see you in the our classes. Thank you all.
Thank you, Malik. Have a wonderful day. Thank you.
Thank you.
Thank you, Malik.
Bye.
Thank you, Malik.